So now that we've filled in the angle measures and the first quadrant values of the unit circle, we're going to see if we can fill in the remaining values just using symmetry. All right, so what I'm going to do first is highlight each line in a different color. So at 0 and at 360, its mirror image is going to be at 180 or pi radians, okay? And what we can do to establish the fact that we're essentially in quadrant 2, we're going to have negative x values and positive y values. Instead of it being positive 1, 0, we'll have negative 1, 0. And then our tangent value, our opposite of 0 is still 0 because of the fact that, 0 does not have a positive or negative, is neither positive nor negative, all right? We'll do the same thing here with this second value at 30 degrees, or pi over 6 radians. Its mirror image in quadrant 2, I highlighted in blue, it's 5 pi over 6 or 150 degrees here. And therefore, the radian values, because it's radical 3 over 2, 1/2, this will be negative radical 3 over 2. Positive 1/2, because it's negative x, positive y. And our tangent values are going to be negative as well. Because again, if it's y over x, we have a positive y, but a negative x value, we're going to have a negative tangent value. The next, we're going to go with 45 here. Its mirror image in quadrant 2 will correspond to 3 pi over 4 or 135 degrees. And again, negative x, positive y, so we'll have negative radical 2 over 2, radical 2 over 2. And the tangent value here is negative 1. We'll go here, at pi over 6. Sorry, not pi over 6, pi over 3, or 60 degrees. Its mirror image is at 120, or 2 pi over 3. And negative x, positive y, so it becomes negative 1/2 positive radical 3 over 2. And our tangent value is going to be negative radical 3. And our last value here at 90, or pi over 2, its mirror image is actually going to be at quadrant 3. At the end of quadrant 3, it goes to 270. All right, and here, because we're at 0, 1, its value here is going to be 0, negative 1 for the coordinate, and the tangent value is still going to be undefined. Okay. Now, how are we going to use this symmetry to fill in the rest of quadrant 3? Well, I'm going to keep on going with the corresponding colors. All right, so if we were to continue with, let's start from the 30-degree angle measure here and kind of continue with that diagonal line. It would go correspond to 210 degrees. And if we were to go to quadrant 4, I'm going to kind of just finish up the reference angles for 30. It would go to 330 degrees in quadrant 4. So therefore, the coordinates in quadrant 3, I'm going to fill this in here. It's going to be negative x and negative y. So it's going to be negative radical 3 over 2 and negative 1/2. Tangent is y over x again. So if these are both negative values, this will actually be a positive 1 for tangent. For the value in quadrant 4 at 330, we're going to have positive radical 3 over 2, because it's a positive x, but then a negative y, so negative a half. And we'll have tangent to be negative 1. Let's fill in the values that correspond to the 45-degree reference angle, or pi over 4. So that would go to 225 here, and to 315 in quadrant 4. So therefore, our values here would be negative radical 2 over 2, negative radical 2 over 2, and 1. Oops, I have to change this value here. For tangent, this value is negative radical 3 over 3. Sorry, positive radical 3 over 3 here. And positive 1 here. This is going to be positive radical 2 over 2, negative radical 2 over 2, negative 1. And I have to change this. This should be negative radical 3 over 3. Okay. The next reference angle, 60 degrees. In quadrant 3, it would correspond to 240 and to 300 here. We've actually we've outlined the entire unit circle and their reflective values. Okay. So we're in quadrant 3 here for 240 degrees. So we would have negative a half, negative radical 3 over 2. And both negatives become a positive radical 3. And this would become positive a half, negative radical 3 over 2 in quadrant 4, and negative radical 3 for the tangent value. Okay. Now you guys should notice that the tangent values as well are the same as the slope of the radius, right? So at x equals 0, 0 radians in degrees, the tangent value is 0. At pi over 2, it's undefined. At pi over 4, it's 1. So what you can think about essentially the all the tangent values are equal to the slope of the radius. Okay, and I'll make a note of that here. So I just put that under the fact that the trig identity that tangent is sine over cosine, which is y over x, and we can see after establishing all these relationships in the unit circle that it's also the same as the slope of the radius. All right, so you can use this as a guide to help you when you guys are filling out your own unit circle.